Welcome to the podcast, Koala Reading AI. I am your host and the voice behind the text-to-speech model. Get ready for an exciting journey through the world of computer vision. In today's episode, we have fascinating papers to discuss. Let's begin with a brief overview of each one. Paper 1, Tracking Anything in High Quality. The paper presents HQ Track, a video object segmentation method that achieves state-of-the-art performance on the Davis benchmark. Paper 2, Scaling Up and Distilling Down-Language-Guided Robot Skill Acquisition. The paper presents a new multitask benchmark for robotic task planning and learning and proposes an approach that efficiently performs task-directed exploration and effectively distills a multimodal, multitask dataset into a generalizable and robust visuo-linguo-motor policy, achieving state-of-the-art results on the benchmark. Paper 3, Scaling TransNormer to 175 billion parameters. The paper presents a data preprocessing procedure for language models, including rule-based filtering, deduplication, and self-cleaning, resulting in high-quality training data at around 2T tokens. The performance with the gate proved to be superior. Now that we have an overview of these exciting papers, let's take a deep dive into each one. We'll explore the abstract methodology and key results of each paper. Paper 1, Tracking Anything in High Quality. Abstract. The paper presents a new method for video object segmentation, VOS, that achieves state-of-the-art performance on the Davis 2017 and YouTube VOS benchmarks. The proposed method, called VMOS, is based on a multi-scale propagation mechanism that allows for efficient and accurate object segmentation in videos. The method is evaluated on several challenging datasets and outperforms existing state-of-the-art methods in terms of accuracy and speed. Method. The proposed VMOS method is based on a multi-scale propagation mechanism that allows for efficient and accurate object segmentation in videos. The method consists of three main components: a feature extractor, a propagation module, and a segmentation head. The feature extractor is based on a ResNet 50 backbone that is pre-trained on ImageNet. The propagation module is designed to propagate the object segmentation mask from the previous frame to the current frame using a multi-scale approach. The segmentation head is used to refine the object segmentation mask based on the propagated mask and the current frame features. The multi-scale propagation mechanism used in VMOS is based on a pyramid of feature maps that are generated at different scales. The object segmentation mask is propagated from the previous frame to the current frame by applying a series of convolutional operations on the feature maps. The propagated mask is then refined using the segmentation head, which is based on a fully convolutional network, FCN, that is trained to predict the object segmentation mask. Results. The proposed VMOS method achieves state-of-the-art performance on the Davis 2017 and YouTube VOS benchmarks. On the Davis 2017 benchmark, VMOS achieves an average intersection over union, IOU, score of 0.727, which is significantly higher than the previous state-of-the-art method, 0.696. On the YouTube VOS benchmark, VMOS achieves an average Jacquard index score of 0.596, which is also significantly higher than the previous state-of-the-art method, 0.578. The proposed VMOS method is also evaluated on several challenging datasets, including the SegTrack V2, VOTI 2018, and VOTI 2019 datasets. On these datasets, VMOS outperforms existing state-of-the-art methods in terms of accuracy and speed. For example, on the SegTrack V2 dataset, VMOS achieves an average IOU score of 0.727, which is significantly higher than the previous state-of-the-art method, 0.696. On the VOT 2019 dataset, VMOS achieves an average accuracy score of 0 paper 2, scaling up and distilling down. Abstract. This paper presents a novel approach to robotic task planning using language-driven robot data generation. The approach involves using a language and vision model to simplify tasks recursively, resulting in a hierarchical exploration plan. The plan is then used to generate a replay buffer, labeled with language descriptions and success, which is used to train a policy network. The approach is validated on a new multitask benchmark, which includes challenging long horizon tasks requiring language understanding, common sense knowledge, tool use, and intuitive physics. The results show that the approach outperforms existing methods and can be used to solve a wide range of robotic tasks. Method: the language-driven robot data generation approach involves several steps. First, a language and vision model is used to simplify tasks recursively, resulting in a hierarchical exploration plan. The plan is then used to generate a replay buffer labeled with language descriptions and success. The replay buffer is used to train a policy network, which is used to generate actions for the robot. The policy network is trained using a distillation approach, which involves using a privileged information policy to collect data and then distilling this data into an observable information policy. The approach is validated on a new multitask benchmark, which includes challenging long horizon tasks requiring language understanding, common sense knowledge, tool use, and intuitive physics. Results: the language-driven robot data generation approach outperforms existing methods and can be used to solve a wide range of robotic tasks. The approach is validated on a new multitask benchmark, which includes challenging long horizon tasks requiring language understanding, common sense knowledge, tool use, and intuitive physics. The results show that the approach can be used to solve tasks such as putting an object in a top drawer, sending a package for return, using a catapult, and balancing a bus. The approach is innovative in that it uses language and vision to simplify tasks and generate a hierarchical exploration plan, which is then used to train a policy network. The distillation approach used to train the policy network allows for the collection of privileged information, which can be used to improve the performance of the policy network. Overall, the language-driven robot data generation approach is a promising new approach to robotic task planning that has the potential to revolutionize the field. Paper 3. Scaling TransNormer to 175 billion parameters. Abstract. This paper presents a new transformer-based language model called Longformer, which is designed to handle long documents more efficiently than previous models. Longformer uses a novel attention mechanism that allows it to process documents of up to 4,096 tokens in length, which is significantly longer than the 512 token limit of previous models. The model achieves state-of-the-art performance on several benchmark datasets, including the Lambda language modeling task and the WikiHop question answering task. Method: the Longformer model is based on the transformer architecture, which has been shown to be highly effective for natural language processing tasks. However, previous transformer models have been limited in their ability to handle long documents due to the computational cost of processing large amounts of text. Longformer addresses this limitation by introducing a new attention mechanism that is able to process long documents more efficiently. The key innovation of Longformer is its use of a sliding window attention mechanism, which allows the model to attend to a fixed number of tokens at a time rather than attending to all tokens in the document. This approach reduces the computational cost of processing long documents while still allowing the model to capture long-range dependencies between tokens. To evaluate the performance of Longformer, the authors conducted experiments on several benchmark datasets, including the Lambda language modeling task and the WikiHop question answering task. The results show that Longformer outperforms previous models on these tasks, achieving state-of-the-art performance. Results: the Longformer model has several potential use cases in natural language processing. For example, it could be used to analyze long documents such as legal contracts or scientific papers, where previous models would have struggled due to their limited capacity. The model could also be used for question answering tasks, where the ability to process long documents is essential for accurate answers. Overall, The long-former model represents a significant advance in the field of natural language processing by enabling more efficient processing of long documents. The model's novel attention mechanism and state-of-the-art performance on benchmark datasets make it a promising tool for a wide range of applications in the field. Thank you for listening to Koala Reading AI. Hope you had fun. The backbone network is responsible for feature extraction, while the AFF token mixer is responsible for preserving spatial structure information during token mixing. The AFF token mixer is composed of two main components: the Adaptive Feature Fusion module and the Adaptive Token Mixing module. The Adaptive Feature Fusion module is responsible for fusing features from different levels of the backbone network, while the Adaptive Token Mixing module is responsible for mixing tokens from different feature maps. The AFF token mixer is designed to be lightweight and efficient, making it suitable for real-time applications. Results: the paper presents qualitative results of AFNet on object detection and semantic segmentation tasks. The results demonstrate that AFNet is capable of precisely localizing and classifying objects in dense prediction tasks with diverse object scales and complex backgrounds. The paper compares the performance of AFFNet with other state-of-the-art methods and shows that AFFNet achieves superior running speed while maintaining high accuracy. The paper also presents visualization results that demonstrate the effectiveness of the proposed AFF token mixer in preserving spatial structure information during token mixing. The paper concludes by pointing out the limitations of the proposed method and suggesting future research directions. Overall, the proposed AFFNet architecture and the AFF token mixer represent a significant innovation in the field of computer vision and have the potential to be applied in various real-world applications such as autonomous driving, robotics, and surveillance systems. Thank you for listening to Koala Reading AI. Hope you had fun.